Session 9.4 Two Variance or Standard Deviation. These sessions, we are working on the hypothesis testing for two populations of two variance or standard deviation. And we will using the F distribution. We call this as the F test for the hypothesis test with the two variance or standard deviation. Requirement: the two populations are independent and has to be simple random samples. And each of the population must be normally distributed regardless of the sample size. So I don't care about the sample size is greater than 30 or less than 30, but the original population must be normally distributed. Okay, notation. Okay, you can see all this notation. There's a 1 in here, okay? S1, N1, sigma 1. This means all this notation is for the population 1 here. And then the first guy, S squared, that is your sample variance. And for the F distribution, you have to choose the larger of the two sample variance as your population 1. That means when you look at two data of the two populations, first you're going to look at the sample variance. Which one is going to be the larger one? The larger one will be your population 1. And then another one will be your population 2. Okay, and N, that's a sample size, and this is going to be your population variance. Okay, properties of the F distribution. The F distribution is not symmetric. It's going to be skewed to the right. Means like the white tail is longer, just like the chi-square distribution. And the values of the F distribution cannot be negative. Okay, same idea as the chi-square distribution. They're starting from 0 and the number is going to be increasing. So they never have negative numbers. And the exact shape of the F distribution depends on the two different degrees of freedom. So look at this picture. This is your F distribution. First, skew to the right means white tail is longer. Cannot be negative because they're starting from 0 and it's a 1, 2, 3, 4 and so on here. So they never have negative numbers. And then they say F distribution, the shape depends on the two different degrees of freedom. If you guys using the table, okay, the F distribution table, you need to find the degree of freedoms for the numerator and the degree of freedom of denominator. Okay, but the changing of the degree of freedom, it will be changing the shape of the F distribution. Procedure for testing hypothesis for two population variance or standard deviation. We'll be using the F distribution. So make sure verify the requirement. And then first step, extract information. So depends on which population parameter they're working on it. Sometimes they're working on the variance, sometimes they're working on standard deviation. And my example here, I will just using the standard deviation here. And make sure when you guys choose the population 1, it has to be the larger sample variance or larger sample standard deviation to be your population 1. Find out the sample size. This part, it depends on what they given. Sometimes they give you the sample standard deviation. Sometimes they give you the sample variance. Okay, either one here. Original claim. If we are working on the standard deviation, so we are compare with two population standard deviation. Null and alternate hypothesis. Again, that's an equal here is always the null hypothesis. Alternate hypothesis will be strictly less than, strictly greater than, or not equal to. And keep in mind for these sessions, when you're using the F distribution, we don't have the left tail test. It's always right tail or two tail. Okay, even though you have a less than, you're still using the right tail. Okay, only right tail or two tail. Test statistic here. So be careful. This is talking about the sample variance. If they given the standard deviation, you need to take the square for it. But if they already give you the sample variance, you don't need to take the square, okay? Just plug it in and divide it to find your test statistic. And one more time, double check, your sample variance should be larger than the sample variance 2 in here. Okay, the S1 has to be larger than the S2. Okay, distribution. We will have the right tail example. Again, we don't have the left tail. So we have the test statistic at this point, and we want to use the p-value method. So the white tail here, that will be our p-value. Okay, when you guys use the calculator, p-value is always using the CDF. Remember, we have a normal CDF, T-CDF, chi-square CDF. Now we have the F distribution, so that will be F-CDF. So we don't have the left tail. It's either like two tails or white tail. So test statistic, the lower value to upper value. And then degree of freedom of numerator. Okay, talking about this one, which is gonna be your N1 minus 1. Okay, degree of freedom is gonna be N1 minus 1. Degree of freedom of denominator, that will be N2 minus 1. Okay, that will be talking about the sample size in here. Okay, we're using the same conclusion when after you find the p-value, compare with your significance level. Less than or equal to will be reject. Greater than, that will be fail to reject. Okay, conclusion, same idea, the 1, 2, 3, 4 conclusions. Okay, next part here, you could use your calculator to double check your work, your test statistic, and also the p-value. But again, this is only for checking. On the exam and homework, you guys need to show me all your work. Okay, example 1. In a series of experiments to determine the absorption rate for pesticides into skin, 2 pesticides were applied to several skin specimens. After a time, the amounts absorbed were measured. Assume that for each pesticide, the amounts absorbed are a simple random sample from a normal population. Can we conclude that the standard deviation of the amount absorbed is greater for pesticide B than for pesticide A? Use significance level of 0.05. So in this chart here, they given the sample size and they also give you the sample variance. So we check the requirement in the independent samples from the normal populations. So again, chapter 9, the first step, tell me which one is going to be your population 1, which one is going to be your population 2. And with the claim statement here, we are working on standard deviation. Okay, we are working on population standard deviation. So look at these two, pesticide A and pesticide B. Which one will be your population 1? Which one will be your population 2? We're gonna take the pesticide B in here, right? Because this is the larger sample variance. Okay, one more time. When you have the largest sample variance or the largest sample standard deviation, that will be your population 1. Okay, so the standard deviation of the amount absorbed for pesticide B, the B here will be your population 1. The A here, that will be your population 2. Okay, now with the claim statement, write down the original claim. You should get standard deviation 1 greater than the standard deviation 2. Okay, state the null and alternate hypothesis. Okay, that will be white tail. Okay, test statistic. Look for the formula for the test statistic. So you need this information. Okay, write it down and then plug into your calculator. Okay, you should get this answer. Okay, this is gonna be your test statistic. So we have the whitetail and with the test statistic 3.833. Okay, next step. F distribution, that will be skewed to the right, okay? Make sure don't give me the normal distribution, skew to the right. And we have the test statistic 3.833 here. Okay, find your p-value. So we'll be using the FCDF, the lower value, which is the test statistic, to the upper value, 1 in 99. So what is the degree of freedom of numerator and what's the degree of freedom of denominator? That will be n1 minus 1 and n2 minus 1, right? Now use your calculator, second, vars, you should find the FCDF. Plug it in, you should get 0.0388. Okay, compare with your significance level. It should be less than, right? So that's a reject. Conclusion, which conclusion you're gonna use? You'll be using the number 3 conclusion. Okay, there is sufficient evidence to support the claim that the standard deviation of the amount absorbed is greater for pesticides B than for pesticides A. Okay, example 2. I want you guys try to do it by yourself. Do step 1, 2, 3, 4. Make sure the first step you're gonna say which one is gonna be your population 1, which one is gonna be your population 2. And with the question carefully, are they working on standard deviation or variance? Okay, we are working on variance, right? You could see tester claim that those tests with a red background have a creative scores with a variation. Okay, this is talking about the variation. So this is going to be the variance. And then which one is going to be your variance 1? So look at the sample standard deviation. This one has the larger sample standard deviation. So the variation of the red background will be your population 1. And then the blue background will be the variance population 2. Okay, what is your original claim? You should have equal to, right? So you should have an equal in here. And then the null and alternate hypothesis. So we will have to tell. Okay, formula. Figure out this 4. Okay, be careful when you guys plug in the information to the test statistic here. We only have the sample standard deviation, but the formula, this is the sample variance. So when you plug it in, make sure you take the square here. You should get 2.371 as your test statistic. Okay. So again, this is skewed to the right and with the two tail. So that will be your p-value, right? So 2.371 will be the test statistic to the upper value 1 in 99. Find out the degree of freedom of numerator and the degree of freedom of denominator. Okay, use the calculator and make sure you multiply by 2, okay, because you have a 2 tail. Okay, the one in here, you only look for the area of the white tail. So now you need to multiply by 2. You could get this one. Okay, compare with your significance level. So less than or equal to will be reject. Okay, which conclusion you're gonna use? That will be number 1 conclusion, right? That's sufficient evidence to warrant rejection of the claim that Example 3. This example will be using the critical value method and 5% significance level to test the claim. So I want you guys to try number 1, 2, 3, and 6. Okay, 1, 2, 3, and 6. 4, 5, 7, 8, we're gonna do it together. So with the questions, again, state which one is gonna be your population 1, which one is gonna be your population 2. And also make sure with the question carefully, are they working on standard deviation or variance? Okay, check your work. We are working on variance. Okay, so for the population 1 will be the potato, and then this population 2 will be the juice fastest in here. Okay, one more time. We're gonna look at the larger sample standard deviation or variance. That will be your population 1. And then what is the original claim? You should get greater than, right? Okay, no and alternate hypothesis. That'll be white tail. Okay, right? Then find out these 4 numbers. Okay, check your work. Okay, now distribution. We will have the skew to the right, white tail. So figure out what is the area of your white tail. Should be equal to the significance level, right? Okay, 0.05 for one tail. So look at the F distribution with the alpha equal to 0.05. Okay, and then we need to figure out what is the degree of freedom of the numerator, degree of freedom of denominator. So I want you guys find out these two first. You should got 60 and 51, right? N1 minus 1, and then 2 minus 1 here. So look at the table with the significance level 0.05, and then we have 60 and 51. So this is going to be the 60, degree of freedom 1, and then go down, we need to find the 51. So you could see we don't have the 51 in here. You could pick either one from here. So I would choose like the 60. So we're gonna pick up this number. This is gonna be your critical value, 1.5343. Okay, 1.5343 here. Okay, write it down. This is your critical value. And then find out the test statistic. Plug in these two numbers here. You should get 1.8138. Okay, and then compare with this picture. Where is your test statistic located? So this is starting from 0, so the number is going to be increasing. Should be here, somewhere like here, right? 1.8138. Okay, your test statistic is located in the critical region, so we're going to reject. Okay, inside the critical region, so we're going to reject. And then the conclusion. So the original claim go to the alternate hypothesis, so that would be either number 3 or number 4. And we have a reject, so number 3 conclusion. Okay, that's it.